Thank you for joining today. And just getting set up, and I'll share my screen here. I see we've got a pretty good group in attendance today, and we're going to talk about the land mobile public safety features in SignalPro, and especially one new feature that we've changed that's kind of under the hood, and you know, if you don't pay really close attention to the release notes, you wouldn't notice it. So we'll kind of give a little bit of an overview, and for a lot of you, I think this will be just a review, but then we'll get into the new feature as well, and I've got an example project to look at. So I'm sharing my screen now, and I've got just a couple of slides to sort of guide me along here, and I'll jump back and forth between the slides and my actual SignalPro project. If you do have any questions as I go along, or you know, would like more information about part of it, please do use the chat and go ahead and enter any questions in, and then we'll have a section at the end where I'll go through and try to answer those questions. And if there's any discussion that we need to take offline and set up a separate meeting, of course, I'm happy to do that as well. If anybody has a new project or a particular challenge they're looking at, do feel free to check in with our support team, and we'll set up a customer success session to take a look at what you're doing and maybe make some suggestions. So a couple things about best practices for land mobile planning. There, of course, land mobile planning for VHF and UHF public safety has been going on for a long time. For decades, the sort of best practices for this have been evolving. And here in the United States, as well as internationally, not only have the actual standards evolved, the P25 standard and the Tetra standard over in Europe, et cetera, but the sort of the best practices that are accepted within the industry for planning these systems have also been kind of evolving. And the new TSB88 studies in SignalPro, I've noticed have started to gain traction, and those are particularly for simulcast planning. The TSB88 committee had recommended some Monte Carlo studies to look at reliability and time delay interference as part of, or fading and time delay interference as part of the same study. And EDX went ahead and implemented those recommendations, and we've improved them just a little bit as well, improved those studies for you. So the three main challenges that I want to talk about today in particularly simulcast planning, but some of this also would apply just as well to multicast or non-simulcast land mobile radio systems. The first one is the fact that the link budget in a land mobile system is very often asymmetrical, meaning that the downlink or the talk out signal can be, for one thing, a stronger signal level, more output power from the transmit receiver, and also the actual path between the base station antenna and the mobile remote unit in the field can be different than the uplink or talk in path. Since the mobile in the field usually has much lower transmit power than the base station, you know, if you've got a 50 watt or 100 watt base station and a 1 watt radio, there's a pretty big difference there in power. And so to help make up for that, we've got very often the base station receiver antennas are higher up on the tower, and we use voting receivers as well. And that we need to take that into consideration carefully when we're doing the planning. And I sometimes see some mistakes out there about that. So let's go ahead and jump into the software and look at just that one. I'll talk about that item first. So here I've got a SignalPro project with just 2 simulcast sites. I'll remind myself what frequency here. Okay, so these are at 460 megahertz, just as an example, and they're set up as simulcast. And the study that we're looking at right now, here, let me go ahead and show first. My receive power at remote study is pretty boring, pretty straightforward. I've got plenty of signal level across the entire area. When I set up my uplink or my talk-in study, I want to make sure that I'm accounting for the difference in base station antenna by, if I've got one height in my transmit antenna here, I may have a different height in the base station receive antenna here. So maybe this one's at 45 meters up the tower or something like that. And in this project here, this is actually just a simple example that I'm going to use to show or talk about the time delay interference problem. So I haven't set that up in this project where I've got the tower receiver antennas higher. But if I am going to set that up, so I go in to both towers here, and in the receive parameters, maybe I make that antenna height higher up the tower. And maybe it's a different antenna as well. I may have a directional antenna on the transmit side, but an omni antenna on the receive side. So I might even set up an entirely different pattern and gain and so forth. And once I've done that, then when I set up the area studies, I can set up a list of the different area studies that I want to run. And when you look at the area study details, you've got an option here for uplink calculation. And we can say, well, just use the downlink path. That's the default choice usually in your when you first add the study. And that's because that's the fastest selection, where it will assume that the path loss for any path is based on the downlink path from the base station transmit antenna to the mobile remote unit. And if the receive antenna is higher, we want to make sure it recalculates the path using that new antenna height, because you may have better clearance over terrain or clutter obstructions, that kind of thing. So we'll select independent calculation here to make sure that the uplink path is always being calculated separately. And it's easy to overlook. And so that's one of the reasons why I really recommend, if you do public safety radio a lot, set yourself up a project template that has all of the different area studies that you're typically going to run for any public safety type project. And then make sure that these options are set the way that you're going to want them, and save that as a project template so that you won't just forget while you're setting up the project, right? Another option here, which I think I call out in my slides as well, is this grid optimized radial option. If you have long range sites, especially mountaintop sites that have a very long broadcast sort of range, the radial lines going out from the site start to spread apart as you get further and further from the site. And so the detail in the study can be a little bit less granular if you're using the radial line method. As those radials spread out and you get further from the site, there's fewer study points, and you can have what amounts to sort of a smearing effect in the results, that it's a little bit less granular than it should be. So the grid optimized radial option As those radials spread out, the software will add additional radials between them to make sure that the point spacing stays consistent and the resolution of the underlying study stays consistent. So again, if we're planning little repeaters that are low to the ground in a urban type scenario, and you've got a lot of them, you may not want to do this because it increases calculation time. But if you've got big long-range mountaintop sites, the grid-optimized radial is a little bit more precise way of running it. So those two options there in the area study details are important to remember. And of course, your base station transmitter versus receiver heights. And then I think that's what this slide's about here. So we just looked at that. Be sure to use grid optimized radial and the independent calculation for those uplink studies. And the next issue is that on those uplink or talk-in studies, the area study type for looking at received power or reliability needs to take into account the voting receivers. And the simple explanation of a voting receiver is that the mobile remote unit transmits the signal out, and any base station that can hear that will be able to receive it. And the strongest base station in any given moment is the one that picks up the signal. So a standard SignalPro uplink received power study will look at the strongest server for each grid cell based on the downlink power, and it'll report the uplink received power for that grid cell and that server, which for other kinds of systems, cellular systems and things like that, that's often pretty much how it works, is the downlink power is what sets the channel that's being communicated over and which base station is being transmitted to and so forth. In a voting receiver situation, you could be receiving the simulcast system from one base station, but then transmitting to another receiver close by that may not even have a transmitter, or maybe it's a repeater in an urban canyon or something like that. So to make sure and take those voting receivers into account, we want to make sure the uplink, if I want to look at uplink received power, I'll choose the received power at best voting receiver from remote study. But this gives you a static received power value only. So it gives you basically the average uplink received power. And so that doesn't take fading into account in the way that our TSB88 simulcast studies do. So instead, if you want to take fading into account and get a reliability percentage for that uplink, you can use the uplink percent log normal reliability using voting receivers. And in that area study, so I can select that here, it will use the standard deviation that I set in the reliability methods for log normal. If I put my typical 5.6 dB of standard deviation here, which is the same that I would have in my TSB88 study setup, that's the committee recommended value for the standard deviation of fading in the system. If you have, for example, a dense urban environment where you have a lot of multipath and a lot of, a lot more fading or deeper fading, you can increase this value, by the way. There's nothing wrong with increasing this standard deviation, especially based on the standard deviation that you see in your drive test data. It's a very good way to make sure that your reliability studies are taking into account that deeper fading. So I would set those values and then add that study for received power at best voting receiver, percent log normal reliability using voting receivers. And that would give me my percent reliability on the uplink case. And then for the downlink case, of course, I'm going to use those TSB88 Monte Carlo studies, probably the aggregate reliability study. So back to the downlink or talk out case. Here, a quick kind of word on time delay interference. The unique thing about simulcast is that if both base stations or all the base stations are transmitting the same signal on the same channel. And so that means that if the signal from my two base stations in this project are aligned with each other in time, then there's no interference. You know, and you can see that in the green band here of my study. This is my simulcast Monte Carlo reliability, and the green areas are areas where I have 99% reliability. I've taken the terrain and the clutter out of this project to show us these sort of idealized, perfect results so that you can see very clearly the effect here that a mobile that's out here in the field exactly between those two co-channel base stations, the time delay between the signals is exactly the same, so those signals do not interfere with each other until you get closer to one base station than the other, so that now the Corvallis base station signal here is going to be the stronger, but the Lebanon signal is still within the capture ratio of the mobile, and it's substantially time delayed. So the Lebanon signal is coming in late relative to the Corvallis signal. And if that time delay is too great, but the power levels are still close enough to each other, then that's what time delay interference is. And basically the receiver can't distinguish one symbol from another. And so my reliability has shot down there until I get so close to the Corvallis base station that the power ratio between the first and second site is so great that the signal level from the Lebanon site is irrelevant, and there's no time delay interference because it's sort of outside that capture ratio. Excuse me, I'm losing my voice a little bit here today. And so it used to be, speaking of kind of older planning practices, it used to be that you would run the coverage study, which would take fading into account as well. You'd put some extra margin onto the propagation model and run just a coverage study to show where you had sufficient signal level from all of the sites. And then you would run the time delay study to show the areas where the time delay interference was too great. And you would basically remove those areas from what you were calling covered for the purpose of saying how much of the area you have covered. The TSB88 committee recommended a new study to look at this problem in more detail because, as we know, signal levels in the field fade up and down over time. If I calculate a predicted signal level of whatever, some average signal level out in the field, in reality, the signal level that you would measure on the receiver at that one location, even if I'm not moving, that signal level is going to be fading up and down all the time. And that's true for both of the base stations. So if the mobile remote unit can hear two different base stations, those two signal levels are fading up and down relative to each other in an uncorrelated way. So that means that the power ratio between the desired and the potential interferer is also changing all the time, which is going to change whether or not that delayed signal is truly interfering or not. And so the TSB88 committee wanted to take into account fading and time delay in one study, and they recommended the study methods that we implemented under the TSB88 study setup here. And I've talked about these before, and I've done a webinar about these before. So just as a quick review, we're setting the tile reliability that we're going for. We're setting the maximum allowable delay time, and we're setting the required signal over interference and noise ratio, or the CPC stands for channel performance criteria. And it's that power ratio of desired versus undesired. Down here, we're setting up the fading portion of it, where during the Monte Carlo trial, we're going to essentially roll the dice for those incoming signal levels over the course of however many trials and report back what percentage of the time that trial was a pass or fail according to the delay spread and CPC criteria. So again, I know a lot of you in the room today are already familiar with these studies, and you're already using these studies because we've talked about them on customer success calls, and we've even got sort of customers out there in the field that are starting to be a little more educated about simulcast time delay issues and are kind of expecting to see these reliability studies. Here's where the big new feature comes in, and I'll switch to my slide now so that hopefully I can say it succinctly, or you guys might just read here. But originally, the Monte Carlo trial method that was recommended by the TSB88 committee was set up to look at a single simulcast group, or in other words, a single channel at any given time. And this is one of the practical difficulties with a lot of these TSB88 recommendations, is that there are recommendations for various different ways to look at individual problems within the network that you may have, but there's not sort of one study to rule them all to say whether the system will work reliably. And so they were trying to get closer to that with the Monte Carlo study that would take both fading and time delay into account when looking at reliability for that talk out case. The problem is most even simulcast systems are not entirely simulcast. One classic example is any area along the beach or with a lot of, canyons or significant terrain. It may be difficult to have just one simulcast channel cover that whole area without time delay problems. And so you may set a few sites, say, for example, looking down the beach, you may have just that site on another channel acting as a multicast site instead. And these sort of blended or hybrid systems that may be simulcast over a huge part of the territory, but then multicast in a few little problem areas, those are really common. Or you may have multiple different simulcast groups within the area where, the radio can switch from one simulcast channel to a different simulcast channel. And if that's how your network is, then previously you needed to treat each of those different channels independently and run the reliability studies for them independently, and to then show a unified coverage and performance map to your customer, you had to somehow join those various different maps together. And I talked to some of you where you were, using some pretty ingenious solutions in your GIS platform, either in ArcMap or in QGIS or whatever, to take the exported area studies and join them together into the map that you want to make. But that was a lot of work. And so the feature request was made to expand those reliability studies to support more than one channel group. And here's where the change in how the study works is a little bit subtle, and you want to watch out for it. So let me go ahead and I'm going to show my aggregate simulcast Monte Carlo reliability study. So again, this study is basing this percentage on what percentage of time the signal levels pass those criteria that I set up. So I've got a required, essentially, signal over interference ratio and a required maximum delay time. But that delay time is only destructive if I have less than the required signal to noise ratio. So, it's only interference, I think I said that backwards. This stuff is hard to talk about. The incoming signal, it only qualifies as interference if it is outside this delay time. That's the direction I need to say that. So, I need to pass my required CPC and my required delay time, and the Monte Carlo trial takes that into account. As the signal levels fade up and down, it's checking against both of them. Previously, in old versions of the software, this was actually a possible mistake that you could make in the software. If I have my other site here on a different channel, so this is an adjacent channel instead of right on 460 megahertz, the TSB88 reliability study was written with the assumption that all of the studies, or all of the sites in the study, are co-channel and part of the same transmitter group. So it was not looking at whether, if I have one site that's on an adjacent channel because I'm using it as a multicast site, the study didn't take that into account. And you could potentially have this site being counted as a time delay interferer, even though it's on a different channel. And that was the feature request that was made was, hey, if I have some of these sites on a different channel, can we still include their coverage in the reliability study and still subject them to fading? But if there's no other site on this channel, then there's no potential for time delay interference. So we just need to look at the fading part of it. And so that's the change that was made. In the new TSB88 Monte Carlo studies, it will look at the center frequency for each of the sectors that are, or each of the signals that are present at that mobile remote unit location, and, or rather the 6 strongest incoming signals. It will take the strongest signal level and assume that that's the center frequency it's trying to listen to. and then it will check for other co-channel signals and treat them to the same time delay interference and fading that the original study did. But now you can have a mix of your simulcast groups and multicast in the same downlink reliability study. And in areas where the multicast channels are dominant, you're going to be seeing the percentage reliability inclusive of fading. And in areas where the simulcast channels are dominant, you're going to be seeing the percentage reliability inclusive of fading and time delay interference. So all of that means that hopefully you'll be able to cut out some of that excess work that needed to be done in the GIS platform to make a finished unified reliability map for your customers. You can, if you've run now essentially the aggregate simulcast Monte Carlo reliability, that will be your downlink reliability, and then the I always forget the name of the study now. Uplink percent log normal reliability. And I want grid optimized radials, an independent calculation. And I'll just go ahead and leave that in my list now so that it's there next time. This uplink percent log normal reliability using voting receivers study is then the uplink reliability percentage. So between those two studies, you can look at your talk in and your talk out case in a nice unified way, taking into account the voting receivers and taking into account the behavior of the simulcast system and the potential for time delay interference. Hopefully that will simplify things for a lot of you. And I'm going to open up the question and answer window here. If anybody has any questions about what we just discussed, please go into the Q&A section and go ahead and type in those questions there. And again, potentially I can address them right here in the session, or if we need to follow up with you after the fact, we can do that as well. Oh, so I've got one question here, which is how you would go about creating a receive-only site. And that's a great question, especially if you're doing simulcast and you have that, again, asymmetric link budget. You may have sites that really you only just need to put in the receiver, and it's just a voting receiver to pick up in areas where the mobile may not have a great ability to talk out from, urban canyons and things like that. And the way I would add one of those is to just go ahead and add a site into the project. And, I'll set up my receive parameters however they are. Chances are this one's going to be much lower to the ground, maybe on a utility pole or something like that. And when it comes to the transmit parameters, you can disregard these, because what you'll do is just leave this sector out of the transmitter group when you run your downlink studies or your talk out studies. I'll set up a transmitter group, and so let me show that here. When I go in, and so aggregate simulcast Monte Carlo reliability, that's a talk out study. And right now I only have my master group for transmitters. So what I would do is go into my spreadsheet editor here, and I'll make a new transmitter group for my talk out. and create that. And then I'll highlight just my main transmit sites here. And I'm going to choose the talk out group, add rows to group. So now those are in there. And then maybe I'll also create a site that's receive sites. And for that one, I would go ahead and add in all of them. Like that. And now when I set up my talk out study, oh, had to get my screen back there. When I set up my talk out study, I'm going to choose just the talk out transmitter group there. And then when I set up my talk in studies, so for example, the uplink using voting receivers, I would choose receive sites like that. Now, that will do it, and really these transmit parameters on the site won't matter at all. I have seen people be sort of worried about that and take their ERP down to some arbitrarily tiny amount of, power. But that works as well. Effectively, you'll see no coverage from that receive only site. But really the right way to do it is to use your transmitter groups. And if you've got some sites that it's there, it's a site, but it's only receive only, just make a transmitter group that has your TX sites versus your RX sites, and be sure to point to those groups in the study like that. Oh, geez, you guys couldn't see what I was doing. I'm sorry about that. Was it frozen here? Can you see this dialogue now? I don't have the chat window open. So I was pointing to the transmitter group talk out here that I've set up in my area study details. And the way that I created that, which I'm sorry you couldn't see my demonstration there. The way that I created that is in the spreadsheet editor tool here, I can create new groups. So, I can create a group like that. And then from master group, I can highlight rows and add them to a group with add rows to group. And so I basically used that to create a group for my receive sites, which is everybody, and then just my talk out sites or my transmit sites, which is just the two main sites. So sorry again about the Zoom controls. So there's a question whether the simulcast study works for multiple simulcast cells, or is it just the simulcast cell and then other multicast sites? And is there a limit to how many hybrid sites the study can use? You can have any mix there. If you've got multiple simulcast groups that are each on their own channel, just make sure that you're coordinated in terms of the frequency that you set here. Everybody that's in the same simulcast group needs to be on the same channel there. There is not a limit to the number of different channels that you can have or the number of different sites that you can have within the study. Well, I mean, there's the practical limits of how many sites you can have in a SignalPro project still apply, but there's no special limit in the TSB88 studies about how many different frequencies it can be looking at, or how many sites can be in the study. The one thing I will say is that the TSB88 simulcast studies assumed a channel plan that does not have overlapping channels. So, it assumed that if I'm using 460 megahertz here and 12.5 kilohertz channels, then the next neighboring channel is going to be 12.5 kilohertz away or more. So it's not going to do like semi-adjacent or overlapping channel interference. If you have some kind of a channel plan like that, then we'll want to run a more traditional C over I plus N study that can look at those overlapping channel powers. And that's kind of a special use case. So if you are doing that, I'd love to hear about it. But bear in mind that the TSB88 studies are assuming that channels are either co-channel and potentially can time delay interfere with each other, or they're non-co-channel and there's basically no interaction. It's not accounting for channel overlap or adjacency in any more detailed way than that. And again, that's because the channels are adjacent channels are supposed to be non-interfering. So under P25. Okay, back to the Q&A. Oh yeah, the noise figure. So the question is, when populating the receive parameters of a site, can EDX calculate a cascaded noise figure? When you have a tower top amplifier, the noise figure of the tower top amp will dominate the noise figure. So we have this tower top amplifier multicoupler option here in the receive parameters. And if you switch that on, you can specify the characteristics of either or the tower top amp or multicoupler. So I would put in the gain and the noise figure of that, and we're calculating those noise figures together with the received noise figure in a cascaded way. If you have a really complex setup, I've certainly, folks have shown me block diagrams for their receive chain, and it's more complicated than this dialogue allows for. If you have something like that, it may still be necessary to sort of calculate your overall system noise figure by hand and just leave this off and put your noise figure in there. However, if you're using kind of a standard installation for a TTA or a multicoupler, these are calculated using kind of the industry accepted method. So you should be safe with just turning that on and putting in those values. A great question. The question is, will the new feature work with both the Hess simulcast reliability or just the aggregate study that we've been talking about? And I believe, I haven't tested it personally on this latest release, but I believe that both study types are doing the same thing, where we've implemented that support for multiple channels into both the Hess study, which the difference there is that the Hess study is looking at the table you provide for simulcast signal versus delay. So if I have my, I don't have one handy here, but if I have that table that describes the amount of delay spread that is tolerable at a given signal to noise ratio, I can input that table here, and the Hess study will use that table instead of these strict boundaries as the criteria. And my understanding is that both studies now will observe multiple channels. Follow-up question on the receiver noise figure, which is, does that account for the feed line, isolators, jumpers, and such? And that's where I think it does not necessarily account for all the connections and every item that you might have in your block diagram. And so, you know, if you're accounting for each of those things specifically, you may want to hand calculate your noise figure and populate that in there. If you do have a use case where, you know, your noise figure hand calculated for each component comes out substantially different. Oh, what am I looking at? Comes out substantially different than what we would calculate here by just turning those on. We'd be interested to see that. I'd love for you to start up a support ticket and just show us what the setup looks like, because this is an area where there's a lot of variability in users. You know, some folks know just exactly what equipment is going to be there, how it's going to be hooked up, and what all the specs are on that equipment. And so they're in a good position to work all of that out. And a lot of the time, a lot of our users may not have that information on hand and are looking for a reasonable estimate. If this is giving an estimate that's way off from what you've come up with, I'd be really interested to see what that is and see where the differences are. So great question, and yeah, it's good to sort of check your work against your hand calculation if you've got something complex. Oh yeah, another great question. Basically saying this would only apply to a limited number of client projects. What would apply to all projects would be a hybrid study that shows where both the uplink and downlink meet a given minimum criteria, and is that possible? At the moment, there is not one single study to do Monte Carlo reliability, and I think that's because, you know, the Monte Carlo study was recommended by the committee, and so there was a lot of sort of traction to implement this new method out there. But there's not necessarily industry-wide agreement on what the right inputs and boundaries are for both the talk in and talk out. I myself, I think it would be great to have, just like you said, the uplink voting receiver reliability study and the simulcast reliability study, and there we'd have to choose either Hess or aggregate, but those two studies combined together to show where you have sufficient reliability on both the uplink and the downlink. I mean, that'd be my one study comprehensive picture. But again, there'd be some choice to make in terms of which downlink study to use and which uplink study to use. So at the moment, we don't have one that includes all of it. You're still sort of in a paradigm where you've got an uplink and a downlink picture, at least the two. I will put in a feature request though to add a study method like that, or there's been talk about some way to combine multiple studies into one picture and one export, and so that, you know, we can kind of throw that into the feature discussion as well. It's certainly we're well aware that sort of time is money for folks doing RF engineering, and so any extra steps that we can cut out of your process are going to have a big impact. But we want to make sure that we do that in a sensible way that's going to be the right choice for at least the majority of our users doing this. So if if you also would like to have that combination of the both uplink and downlink reliability, or maybe uplink and downlink coverage, there's some options there. Again, do feel free to reach out to us either through your account manager or putting a ticket in on the support portal. And if there's something you'd like to see, let us know. And if we see that multiple folks are asking for the same thing, we'll try to go out of our way to fit it into the roadmap for you. Yeah, I can see folks are joining in on, hey, this wouldn't be too hard to make a joint uplink and downlink probability map. Yeah, I agree. It might be sort of a low hanging fruit from a programmatic standpoint. So I'll put that feature request in, and we'll see what we can come up with. Thank you everybody for joining the session today. If you have any other questions, or again would like to talk about your project and take a look at what you have going on in SignalPro right now, please do reach out to us. And I hope to talk to some of you soon. I guess we'll give you back 5 minutes at the top of the hour here, and I'll go ahead and end the session. Have a good day.